most valued student. My name is Confident. Welcome to our revision session of Engineering Science N3, where I'm looking at part 2 of revision on forces. And in this particular section, I want to revise one of the questions that was brought in November 2019 paper. As you can see, this was Engineering Science. And there is a section on forces. That is question number 3. And you can see question 3 is 14 marks, and this was a question on forces here. Just to bring it, so this is what we're having on forces. It says in this case question 3.1 was the first question here. I hope it's clear. Maybe just to make it a little bit bigger. Question 3.1 was saying what is the relationship between the resultant force and the equilibrium of a system of forces. So that's what they wanted you to give 2 marks there. So the resultant force, the relationship is what they wanted. How are these related? Resultant force and the equilibrium of forces. Now remember, both resultant and equilibrium, they are equal in size. And then that's the first part. The relationship is they are equal in size, and then but the only difference is they are opposite in direction. So they are equal in size, opposite in direction. That's what you needed for that. So in other ways, if you have your resultant facing this direction as your arc, your equilibrium similar in size will be facing in the opposite direction, acting on the same plane. So remember that part. That's what they needed for you to get the 2 marks. Now let us look at the calculations, which is the main part of the lesson. 3.2 says the following data refers to 4 forces acting on a point. So we've got 40 newtons north, 25 newtons west, 35 newtons east, 30 degrees north, 30 newtons east, 60 degrees south. Now calculate the following. First question says calculate the sum of the vertical components and state their direction. 3.2.2 calculate the sum of the horizontal components and state their direction. And 3.2.3 says the magnitude of the resultant force. And just look at the mark allocation for that. This was 9 marks, a good 9 marks for you to take advantage of. Each one was 3 marks. So I'm going to do this on a fresh page. So what they have here, I can do this. We are saying if I'm to draw these forces, just to make it in a way much clearer for you. So we have got my Cartesian plane like this, and in the Cartesian plane I have got my y and I've got my x. That is the first part that you need to know. So it says refer to the data here. So first thing that we have is 40 newtons north. So how do we draw that? I will have a line that is along the y-axis, and that line here will represent the 40 newtons. So this is my 40 newtons. Why is it the north? And remember, this is on my cardinal points. I have the north, the east, the south, and the west. So that is what I'm in the west here. That is what I'm having. So the first one is done. The second one says 25 newtons west. So if I come here with a different one again, for example this one, and say 25 newtons, a little bit smaller. So this one will be 25 newtons. The arrows are very important in this case. And then the next one is 35 newtons east, 30 degrees north. So we have got east is for the size is 35 newtons, but it's east 30 degrees north. Where you start from east, moving this direction to the north. So they are saying is 30 degrees, so it's east 30 degrees north. So you start from east, you draw a line they said the size is 35 newtons. So you draw that line like that, and remember the angle is 30 degrees. So it's east, start from east, move towards north is 30 degrees, and this particular force is 35 newtons. That's what they're saying. And then the last one that you are having is 30 newtons east, 60 degrees south. So it's 30 newtons. Now you start from, is it east? Actually, it's 30 newtons east, 60 degrees south. So let's go to east. Now we are going towards south. In this case, from east to south, this is the direction, because if you look at it, it says east to south. So, and it's 60 degrees. The size is 30 newtons, the angle is 60 degrees. So you come here and you draw that force to say, here we have an angle. I actually want the white one. So I've got an angle like that. It is 30 newtons in this case, with an arrow like this to say the angle is 60 degrees and the force is 30 newtons. So that is what they wanted to bring about here. Now you can resolve all these. Remember, I did, just to remind you, there is a part 1 lesson that I did where I was showing how you resolve. I will encourage you to check that lesson on our YouTube channel. Remember also to subscribe to our channel so that you can be notified of more videos, and share this channel with others so that you can benefit. They can benefit also. So now look at this. If I now start, this is the final diagram. So I start resolving vertically and horizontally. So now in this part, I have got the vertical component here. The vertical component of this will be, in this case, is 35 sin 30. So you see that one? And then the horizontal component, which is in this direction, will be, if this is a horizontal component, it will be 35 cos 30. Are you seeing that? And then the one that is white is also similar like that, just to show the difference there. So for that, on the arrow, which is the vertical component, VC, it will be similarly also 30 sin, in this case the angle is 60, and the horizontal component, now just to write it there, that horizontal component there, HC, will be 30 cos 60. We say that. So those are the two forces that needed to be resolved. Now the question then starts by saying, calculate, the first one is, says the sum of the vertical components. Let's do that, then we'll do the direction later. So when they talk about the sum of the vertical components, you can see that in this particular case, we can say, let this direction be negative and let this direction be positive, which is right hand side positive, left hand side negative, and then up positive, down is negative. So it's very important for you to know or to state your direction, so that you'll be able to answer the second question. It says state their direction. So now if I look at this part now to say vertical components here is equal to, now if up is positive, I had first one is 40 newtons plus 35 sin 30 is also facing up, and then I have now minus 30, the white one is minus 30 sin 60. See that? Then when I use the calculator there to find the final answer of the vertical component, it will be 40 plus 35 sin 30, and then actually it's plus bracket minus 30 sin 60. That's how you are adding them, but because it's facing the other direction, you have to put a negative. Now I put too many brackets there. Is 31,519. So that is 31,519. That's newtons. So we have got the vertical component there. Now they said state the magnitude now and state their direction. Now the fact that the sign there is not shown, it means it's positive. So it's 31,519. In which direction? It is east, or you can say to the right. They will mark you whatever way. Now let us look at the horizontal component. For our horizontal component is equal to, you look now at all the horizontal components. Remember, the right hand side is positive, so we have 35 cos 30, which is facing the right hand side. We also have 30 cos 60, but now the 25 is facing the opposite side, so it will be minus 25. So in a way, as I said, you write it, you are adding this, you say plus bracket minus 25, which is the same as just writing the negative. So when you do that, you'll be having 35 cos 30 plus 30 cos 60 plus negative 25. Just to check if I did put the right stuff there, and then equal to, then you press SD, is 20,3108, which is 20,311. So I have got that one, 20,311. It's newtons. Now it's again it's positive, so it means if it's positive, it is the one actually that is east or right. So I was actually writing the wrong one here, because the horizontal component is the one that is east, as you can see there, east, but the one that was positive in the first one, vertical component, is the one that relate to the north or the y-axis. So I was supposed to say it is up because it's facing upwards, or to the north, depending whether you're using north or up. So this is just correct that. So now that I've done this is what they needed for my first sum of the vertical components, state their direction. 3.2.2, sum of the horizontal components, state their direction. So that's what I was doing when I was answering the first and the second question. Now the last question that they are requiring here to do is say the magnitude of the resultant force. So the magnitude there, if I can come now and look at now to say magnitude of resultant force, just to number, this was our 3.2.2, this was our 3.2.1. Now we're looking at our 3.3.3. Now when they talk about the resultant, you must always remember this is the theorem of Pythagoras, because in a way what you are having is, if I can just quickly sketch this, you are having now this let me have this is what you are having now. So you have got that as your y and that as your x, and you have your resultant. Remember, it was to the right as well as upwards. So this is the resultant, which is in this case R, and is facing that direction. So if you look now with the theorem of Pythagoras, you have that part and you have that part. So now you have to resolve this to say that resultant is what we are going to be looking for, because the magnitude of the resultant. So what you have now to find, this is your VC and this is your horizontal component. So now to find the resultant there, the magnitude, you are going to use the Pythagoras theorem, which says R squared is equal to VC squared plus horizontal component squared. So your R is square root of the VC squared. In this case, our VC was 31,519 squared plus HC squared, which was 20,311 squared. So this is actually what you're doing. That is the magnitude. And if you go on to say R is equal to, so to find that, it's square root of 31,519 squared plus 20,311 squared. So if you do that, you are going to have 37,496, that is 3 decimal places. So you can see that 37,496 there. That is the resultant force there, which is what I'm supposed to write there as my 37,496. That is my resultant force. Now the question here was saying we need to find the magnitude of the resultant force. Now in a way, most of the time they don't just leave it like that. They'll say the magnitude and direction. So now, because they didn't specify the direction, you can leave it like that, because a vector, remember, has got a magnitude as well as direction. But just how are you going to find the direction? For you to find the direction there, if I say the part on direction, you have to use 10, which is 10 theta is vertical component over horizontal component, such that theta is equal to arc10 vertical component over horizontal component. That's how you find the angle there. So it will be arc10, your vertical component, remember, is 31, which is the VC part there, without the squared though, 19, over horizontal component, which was 20,311. So when you do that, you will then find that angle, and I will show you shortly. Arc10, 31,519 over 20,311, and if you do that, you're getting that angle 57,202. See that? 57,202, that is degrees. This is the angle theta. Now what is that angle? It is this angle that you're finding, which is 57,202. So what is that angle? It comes back, it's not just, remember, it must, the angle on its own, that angle is just a scalar quantity. Now you need to give us the direction of it. You remember that this is your north, your south, your east, and your west. So you can see that we are going in this direction. In actual fact, the arrow goes that direction. So if we're going this direction, you start from east, then angle, then north. So you're going to say east, then the angle is 57,202 towards the north. That is how you find that. So this is the whole part. If they say, now if you're going to write the final answer, you're going to say, therefore, a resultant is, then you're going to say 37,496 newtons at 57,202 east, actually at east 57,202 north. That is actually what you needed there. So that is how you can now conclude your answer. And guys, it was 3 marks, but the total of this was 9 marks. So I will encourage you to go through these and revise them, and remember to subscribe also to our channel so that I will bring more of these revision sessions to ensure that you pass your engineering science with good marks. I hope this is of benefit to you. Thank you.